Hello, everyone. Thank you for coming. And we have today the priority should be about your exceptions lecture because that's also covered in your coming written test one, starting from Thursday. So we'll focus on the Google Doc questions first, and then if you got any follow up or any question you want to you come up with on the fly, you're welcome to ask me. And then if time permitted, I can either go through some questions on the practice test for your written test one, or if you want to discuss maybe some general hints about lab one, I'm happy to do so. But let's do that at the end. So the priority should still be the exceptions lecture. That's what this session is mainly meant to be. Okay, let's now get started. So quick announcement, okay, just to remind you. So the only thing I want to say is about your lab one and also your written test number one, right? The deadline have been specified very clearly and explicitly in their instructions. I just want to remind you for both lab one and also for your written test one, notice that for lab one it's actually 2 p.m. on Friday, right? So all the labs will be due at the same time. It's going to be 2 p.m. on Friday. And then for your written test one, if you really decide to only take it on Friday morning or maybe Friday afternoon, early afternoon, you have to be aware that you may just want to get your lab submitted first before you take the written test, or vice versa. If you decide to only submit your lab number one on Friday, maybe early afternoon, in that case, you still got to remember you actually complete the written test beforehand. Okay, just to remind you. The last time the submission for written test one is going to be closed also at 2 p.m. on Friday. But of course, the written test one has the 24-hour period for you to submit. So you definitely don't want to wait until the last minutes. Okay. All the coverage, all the policies about written test one has been released since last Thursday. If you got any doubts, you can also ask me to clarify. That's fine too. Okay, for your lecture week number 4, that one is about how you can use the JUnits to do test-driven developments. Especially, I try to incorporate many examples about how to test for exceptions. So lecture week number 4 will also help you later for your lab number 2, which will be released on Friday as well. I'll try to release it by the end of Friday. So you got close to about 2 weeks to do your lab number 2. Okay. All right, so that's about the announcement. And always remember to actually refer to the course calendar. Let me just let's read it together, and then we'll get to the questions on Google Doc. If you look at the semester calendar, notice that we are now around here. 29th is today, right? We are here. And then you can see we got 2 things happening on Friday, right? Your lab 1 is due over here. And also your written test 1, the last submission period is also around 2 p.m. on Friday. And also your lab 2 will also be released. And next week of Thursday and Friday, you will have your programming test number 1. I'll try to release the some practice test and guide, hopefully by the end of tomorrow, if not earlier. Okay, so you also got about a week to actually get prepared. Okay. All right, so I got one question here. Is week number 3 lecture on the written test this Thursday or Friday? Check your guide on the written test 1. You will see a precise answer over there. Okay, I'll encourage you to do read a PDF. Otherwise, you'll miss some other information. Okay. All right, and then after programming test 1, we'll move on to reading week, and then after the reading week, we'll cover the more advanced stuff. Okay, especially inheritance. Just stay tuned. Okay. Any other administrative questions you guys might have? Go ahead if you want to ask before I go on to the Google Doc questions. Anyone? Anything unclear to you about what's going to happen for the course? Everybody's okay? Okay, hearing none, I presume everything's clear. Let me now move on to the Google Doc question. I saw about 3 to 4 questions there related to exceptions. They are not that tricky. It's mainly just about clarification and also giving you some general hints. Let's just, excuse me, let's go over them. And then if you got any follow-up, you definitely got a chance to ask me, okay? So the first one, let's read the question together. In the class A, so we are talking about the to handle or not to handle, the 3 version example that I spoke about in the week number 3 lecture, okay? In the class A, in negative value exception, well, when you throw the exception, we pass a string for initialization of that exception objects when it was the abnormal case. The part from the catch method got printed into the console. Specifically, what is the point? Why are we doing that? Of having an argument pass over the exception. Okay, so this might be worth clarifying. So what's really the purpose really is when the exception is actually somehow thrown or thrown to the console, for example, you can have more detail about it. Okay, let me just show to you here. So you can see the class A, that's what we have here. And when you say throw new negative value exception, you actually put a string over here to say negative value colon and then the value that's being passed, right? If that's negative, then there should be an error, which will be thrown as an exception, right? So where can we see the effects of this? So for version number 3, okay, so that's something you can check. For version number 3 of this particular example, I'll run it together with you as well. You will see that when the exception was thrown to the console, this is some additional information that came from this particular string that we set, right? Here we say negative value should be some value, and this is impacting about what this console message will be. Okay, let me show to you very quickly, and that's something you can also play with. Let me go to Eclipse. So if you go to that project, and let's go to version number 3, okay? Right, you can see at the moment we got a tester over here, right? You can see none of the callers on the stack is going to catch the exception, right? Which is okay. All of them actually chose the specify option. So if I run the program, let me enter some invalid value, let's say minus 20. All right, if I do that, you can see this exception is actually thrown to the console. And remember, we explained in the lecture that this part over here corresponds to the call stack. The call stack is a very crucial concept you have to understand. Later on, when we get to the topic of recursion, we have to also make use of the notion about stack, call stack specifically. Okay, so this part I assume you're okay, just about how to read the call stack. And then you can see this part here is really some additional information about the exception that's being thrown. If you look at the exception there, so the first part is about the package it is from, and the second one is about the name of the exception. And this negative value minus 20 here corresponds to, if you go to class A over here, that's the negative value over here, right? If you don't quite like this particular message here, you can customize it if you wish. For example, you might say negative value. For example, I'm just changing that so you can see the difference, right? If I do that, and let me go back to tester, if I run it again, let's say minus 20 over here, you will see negative value, minus 20, right? So you can definitely control about what message you want to print out to over here. That's completely up to you. But I would say typically, you really should use this overloaded constructor to pass some information about the exception. That'll be very useful. Okay. All right, any follow-up question to this about the first question here, just about passing the argument to the constructor for creating exception? Any question? Anyone? All right, hearing none, let me now move on to the second one, okay? The second one is a little bit long question, and I try to give you, just revisit the two lecture examples that we spoke about. Let's just read through the question first. Okay. So here, for version number 2, again, we're still talking about the to handle or not to handle exception. Okay. For version number 2, let me just remind you for version number 2. Version number 2 goes like this. This is where the exception was originated, and then it will typically just be propagated to its caller over here. However, for this particular caller beta.mb, it also chose to not to handle the exception. It will just propagate it further by specifying it. So that's why it will be also propagated to over here. And then for this final method in the call stack, the bottom one, we're actually saying that for tester domain, we decide to actually catch that. So that's why the exception will not be thrown to the console, right? That's version number 2. That's something you should really review before the test. Okay, let's say this is the version number 2. And since we are catching the exception in tester domain, right? That's what I just said. So here, this is where the exception was caught. Okay, let me just remind us here. this is where the exception, negative value exception more specifically, was caught. Okay, just make a note. On the other hand, this top of the call stack over here, this is where the exception was thrown or originated. So this is where the exception was thrown. Okay, and the question of your fellow students somehow focuses on why we still have some method in the middle over here, right? Let me read through the question and I'll give you some examples. Okay, let's see this. Let's see. Why do we have class B in the middle over here? Can we not just specify the exception directly from class A, which is over here, and then to tester the main without having class B? So the question was, why do we have this intermediate method here? Okay, let me respond to this quickly. In general, the size of call stack will not be just 2. Meaning that you can see in this case, we got a call stack of size 3. We got initial caller, which calls this, which calls that. So we got 3 methods in the call stack. Realistically, you will get a much larger call stack size. So this one is only for simplicity, for illustration. So the case that your fellow student was talking about is it possible that we simply don't have this method in the middle, and then whatever that's being thrown from A.MA will just be maybe handled in this class over here. It is possible, but it does not happen that often. All right, so that's something I want to mention. So it's possible for a Callees exception to be handled by, okay, I'm running out of space already here, by its caller immediately, right? Just one level without propagating further. But this does not happen often. Very often you have to propagate the exception for several levels before it's finally handled, because typically you got a very large call stack. Okay, but this does not happen often. Okay, and then let's go on with the message, with the question. In a general case, if an exception is thrown at the top of our method stack, let's say it's thrown from here, shouldn't the exception be specified to the caller coming after that? Shouldn't the exception always be caught right away by this? Not necessarily. That's why we spoke about the catch or specify requirements. For the caller, for the immediate caller over here, they may choose to either specify or to catch, but it doesn't. It's not necessarily the case that which one should really happen. Which one that should actually happen depends on application. Okay, so there's no right or wrong. So let me also mention that over here. Okay, for this immediate caller over here, so you can see this exception comes from here, right? So this is the one. Let me just emphasize that. And for this one over here, let's mention that to catch or specify. Either way is actually valid. You cannot say which one must be the case always. You cannot say that, right? Either way. And why should we just have another caller after the place where the exception was thrown? So why do we have method class B over here? Okay, why? So again, that's really up to the application. I'll just give you one example, in which case this will be quite sensible. It really depends on the application being built. And this actually happens very often. You cannot just assume that the exception will be caught right away by the immediate caller. let's revisit this particular example here on your lecture, right? The same lecture, okay? And I just want to revisit this point here. Shouldn't the exception be specified to the caller coming after that? Again, not necessarily. Let's revisit this example quickly, okay? So if you remember this example about a bank, right? Also we did in the lecture, okay? So what's the call stack? Let's revisit quickly. So we got bank application, and then the main method. This is entry point of execution. So we got our bank application dot main, which actually make a method call to b.withdraw. And what's the type of b.withdraw? B, the context object over here is actually bank, right? So that's the callee. So that'll be bank dot withdraw, which will bring us to bank and then dot withdraw over here. And then we are trying to make a method call over here, accounts I dot withdraw over here. And accounts I, as we explained, is actually of type account, because you got account array over here. So every member there should be an account. And account dot withdraw, so that will be the top of the stack, account dot withdraw. Notice that even though these two methods have the same name, but they belong to different classes, so don't get confused. And then when we go back, go to account withdraw over here, we have no further method call over here, but this is where the exception was originated, right? So that's why when this particular exception is thrown, it will be propagated to its immediate caller, which is here, the exception. However, whether or not we should really handle that particular is called invalid transaction exception. Whether we want to handle that exception here or not is up to us. We can choose to specify it, or we can choose to catch it. It really depends. But in this particular application, we kind of leave all the exception handling about try and catch to be done at the last level, at the bottom of the call stack. We don't want any intermediate caller over here to actually handle that exception. Okay, I'll document it. It's kind of implicit from what I said in the lecture. Okay, so for this particular application, we only handle the exception which was propagated from the top of the stack, right? You can see exception here. Let me just try to show you that. It's also going to be propagated to there, right? We only handle the exception in the console app class, because, so what's the rationale for that? You can see this amount A over here, and this amount A over here, and also this argument A over here. So where was the A originated from? It's actually originated from this particular line over here. This is the line where A is read from the user. Okay, so this is the origin of the invalid input. For example, if I put maybe minus $500 to be withdrawn, in that case, apparently that's invalid. So that's the origin. So that makes sense to only handle this exception over here in this class, bank application. All right, because this is where the amount is read from the user. Okay, so that's just one example. Okay, back to the original question. Shouldn't the exception be specified to the caller coming after that? It may be, but it may be not. But realistically, I think most likely we are going to propagate the exception by certain callers, by propagate certain levels, and then and then eventually it will be handled somehow. But exactly where the exception should be handled is really up to the design of your classes. But you cannot say that since this is thrown over here, we must handle over here. No, that's not actually what the catch will specify requirements require you to do. Okay, any questions up to now about the catch word specify requirements? Anyone? Everybody is okay? Well, so I presume everybody's clear, right? If you are still confused about the catch word specify requirements, I think either you want to ask me now or you want to revisit the lecture. It's actually quite important concept. Otherwise, you're not ready for Friday's test. I'll pause for a moment to see if anybody want to ask any clarification question to see. Okay. All right. Any follow up to this about catch word specify? Okay. Hearing none. Let me move on to the next one. Okay. The next one, it's more like a general design question. Should we do exception handling as we develop our program, or should we finish the program and then do it? I would say there's no clear cut about which one you should really opt for. I think realistically, you may just have to do both. Okay. I also put some write up response in the Google Doc, but let me just reiterate the points quickly. So you can think about in the design phase, right? When you are trying to sketch the design of your classes, right? In the design phase, you really want to have some idea about the list of errors that might occur in your system. Okay, the list of errors that might happen in your system. For example, you may have maybe a withdrawal error. Maybe you have some deposit error. Okay, different error over here. Okay, and then when you move on to the implementation phase, those initial lists of errors should be converted into exception classes. So when you move on to the implementation, okay, so when you move on to implementation there, what you should do is for if every one of them, for example, for withdraw, you're going to convert that into the withdraw exception class. Okay, exception class. And also for deposit, that should just correspond to another exception class. So that would be deposit exception class. Okay, so that's at least the classes you should really start with when you start your developments. Okay, however, as you go with the implementation, it's actually very likely that you might find out maybe I should really have more error kinds in order for my objects to work properly. So it's very likely that you may have some additional lists, like extra. You may have some extra exception kinds, and that might be the stage to also add them up to the list. Maybe you decided that maybe I should have also another exception, maybe for transfer. And in that case, you also add them, right? And then they'll somehow work together. Okay, so exactly where you should really design the exception classes, there are two timings. Number one is when you are in the design phase. You can just sketch about the initial list of errors that you might have. Each one of them should be converted into exceptions. But while you're still doing the implementation, you might just add more into the projects if you wish, right? So these are the two timings for adding exceptions. So I would say both. All right, that's a very quick clarification to your question. I think that for your later labs or programming test, usually we will only focus on this case specifically. So which means the JUnit test case that you are given, they should indicate all the exceptions you need. You don't need to create any extra ones beyond what's being required, by to you. Okay, any question to this? Any follow up to this? Everybody's okay? Okay, hearing none, let's go on to the next one. Okay, so now let's say, what about the next one? What if we call two or more methods inside a try block and all of their callees throw exceptions, right? So now I'm simply just trying to give you some example over here. Let's say we got this fragment of code, right? You saw that earlier, okay? And here's my question to you. What if the user actually try to put, for example, let's say A over here is going to be, let's say the amount is going to be invalid. Let's say minus 5 million. And also the radius is actually going to be minus 5. According to the current code fragment, what should be the console output? So you can take that as a written test question. Okay, I'll wait for your response on the chat over there. Anyone? Yes, I can repeat the question again. Over here, we have basically two inputs over here. We're considering this code fragment, right? This is something from your lecture. We got one invalid input here for radius. We got one invalid input for the amount over here. If we use these two invalid inputs over here, if we try to execute this block of code as console application, what's going to be the console output? Here's my question. And notice that we got system. Let me just highlight to you. Here we got system.out.print line. Here we got system.out.print line. And here we got system.out.print line. Okay. And for simplicity, I'm just going to delete these two lines just for simplicity. Okay. Okay. With these two input values, what's going to be the console output? That's my question. I see one answer over here. Anyone else? I'm asking for console output. Okay, you guys are not being very exactly precise, but I can see what you mean. But in the written test, you gotta be more precise. What happened to the invalid radius exception? What happened to that? Minus 5 is invalid. Why would that not be part of the output? Anyone want to justify? So here we have Sam and Ann, right? So Sam and Ann, you want to speak up? Just tell me that why you think we only got invalid transaction exception, but why not the other one? Minus 5 is also not valid. Why do we not have that as part of the console output? Why? Okay, I can see your answer here. That's more or less correct. Yes. So the principle you want to follow is only the first exception in the try block is going as soon as the first exception occurs, it's going to disrupt the flow for the rest of the execution. So here you can see the very first one that's going to throw the exception is this one here. So this is the first one, right? That one is going to correspond to the minus 5 million. As soon as it happened, it's actually going to be disrupted and go to over here. And that's going to be the output, right? So even though conceptually you can think about this will throw an exception, this will throw an exception, but in execution time, only the first one will be caught and then disrupt the rest of the flow. Okay. All right. Any question to this? That's something I hope that's clear from your lecture. Okay. Any follow up to that? Anyone? Okay. So hearing none, I presume everybody's okay. Any follow-up? You still have a chance to ask. Okay, is it, okay, here I see one comment that's very useful to know. Okay, sure. So I think one thing you should also try is, as soon as the first one is actually has happened, you will immediately break the flow and then go to the catch and then finish the rest of the code. It's not even going to get to this line of the code, right? It's really important. And then is it necessary to include the system.out.print line in the try block? I would say depends. If we are talking about console application, if you really want to have some intermediate system.out.print line, it's completely up to you. But when you actually develop any try and catch in the model package, remember in the model package, we never put any system.out.print line. Okay, let me just put it here. Okay, let's say if we are wondering about, let's say here, can we put system.out.print line in the try block? Okay, so the answer is, if in the context of console application, like a main method, then yes, you may. But it's kind of up to you. Number two, however, if we are in the context of, let's say, model classes, classes in the model package of model classes, then no. You never ever put any system.out.print line statement in the model classes. Instead, there will be something you can do in the JUnit test cases. That's something you will see later in the lab too. Okay. If you actually also want to put the system.out.print line, let's say outside this particular try and catch block, for example, you can see try statement, try block, which got two associated catch block. You can also put system.out.print line outside of this if you wish. Again, if that's a console application class, it's actually possible. Okay. All right, very good. All right, guys, you're very quiet today, right? I'll take, for me, I can only take silence as an indication that you're okay. All right. If you really got trouble, you have to tell me. All right. Otherwise, I can only assume you're fine. Okay. Okay. Any follow up to this? All right. If no, final one over here. Similar idea. Okay. Why do we only need one try block? It's a very good question, actually. Okay. Can we do two try blocks? And then if the second is invalid, then the user only has to re-enter the second. Okay, basically, can we have two try blocks? The answer is yes, you can, but you just have to know the consequence. Okay, let me show to you this. Let's say, it's a very good question over here. What I will do is I'm going to put it side by side over here. So let's say this is one version over here. And let me just create another version. Okay, I think that might just be fine. Okay, so we got two versions over here. Again, for version number one, that's what you learned from the lecture. So we got one single try block, and we got two different catch, right? Let's now talk about the alternative that your fellow student was suggesting. Okay, the alternative goes like this. So we still got a try block over here, but now let's say as soon as after this, but you know what? It might be better if I can just rewrite it. Okay, how about just rewrite it, just to show you. Otherwise, maybe too messy. Let's see. And by the way, having either one try block or several try blocks, that's also discussed in week number 4's lecture. We also got some more advanced example combining with JUnit test cases. That's something you should also review. But let me just talk about this one specifically. Let's say we got the following code. Let's say here, version number 2, right? So version number 2, we got multiple try and catch. Okay, let's see how version 2 looks like, and then we're going to compare version 1 versus version 2. Okay, so it's still going to be, let's say, double over here. R is going to be equal to some value over here, and also double. The amount is also going to be some value here. And the first try block, we're going to say try, and then here we got bank B, right? You're going to initialize the objects, and also you can say b.add account, and then you're going to set it up, okay? And then b dot, let's say deposit, okay? Let's say so far it's okay, right? And let's now try to see this particular line. If I say b dot withdraw, and then let's say 34 and then A, right? And I'm going to terminate the end the first try block right away over here. And then we're going to say catch. Because we know that this method specifically can only throw invalid transaction exception. That's why we'll only put invalid transaction exception here. Exception, okay, here. And then it's going to be the rest, right? It's going to be some body of implementation for the catch block, right? So far you can see the idea. Let me just continue with it. What about the second try block? That's going to be independence. So let's say we also do try over here, and then we're going to continue with the line to the circle. Okay, so I'm going to say circle, and then C is some new circle, and then C dot set radius, and then some value over here, okay, and then try. And what about the catch? So here there's only one catch block that's needed, because we know that this method here can only throw negative radius exception. So that's the only exception we have to list over here. So we're going to say negative radius exception over here. Okay, and then the rest will be something like this. Okay, I hope the overall picture is actually clear to you over here. And now here's a question. Which one to use, or which one should be more correct? There's no right or wrong answer in this case. I don't see any logical error over here if you use one but not the other. It's really up to what you would like the program to behave. Okay, but we should really tell the exact difference between these two. So this can be another kind of like a written question for you. Okay, maybe more like an exam type. Okay, can anyone try to explain to me on the chat, or if you want to speak up, what's really the difference between version number 1, where we got only a single try block but with the 2 catches, versus version number 2, we got one try and catch. The first one is here, the first one, and also the second one. Okay, what's really the difference between the two? If you believe there's a difference, tell me exactly what it is. If there's no difference, just say no.
I think there's a difference.
You think there's a difference? Okay, how?
So if we have both A and R are negative,
okay,
in the first on the left, we will only be able to get one exception. But
okay, good.
On the right, we will be able to get 2 exceptions.
Okay, awesome. Can you let it is a correct answer, but can you elaborate a little bit more? Why in the version number 2, the right hand side, this version over here, why, let's say both the amount and the radius are negative, why would we get 2 exceptions? Why?
So because let's take look at left. Say if A and R are both negative.
Yes.
So then because everything's in one try block, so it will exit the try block once it hits the first exception. Okay,
good, awesome. What about the right hand side?
On the right, say if both are negative, so because the first try block is going to we can have one exception.
For example, this one here.
Yes, if A is negative, and then when we hit the second try block, the C negative value will also trigger a second exception.
Yeah. Okay, good. Yeah. The only thing that I wanted to hear, but you basically hit that point already. I think that it's really important to know that this try catch and this try and catch, they are independent. Meaning that catching an exception in this block is not going to impact the flow for this one. You will just execute it anyway. Okay, very good. All right, so let me summarize what the difference is. Okay, so here, like this. Let's say if this particular line over here, let's say A here is negative, right? If that's negative, so the execution flow will go in this way. So that means we're gonna execute here, and then the try block, and all these, everything up to here, and then the flow is going to be disrupted, and we'll go directly to where the catch is to catch that invalid transaction exception. That's exactly what will be thrown. And once you go to that catch block, you're going to execute whatever that's inside. After this, you're not going to return back to here because the flow has been disrupted already. So that'll be the flow. Okay. On the other hand, on the right-hand side, let's say if we also try a negative value. Let's say negative value over here. Let's say negative. And also we try some negative value over here. Let's say for the radius as well, right? Two invalid inputs. Let me use a different color here. What's going to happen is we're going to set these two values, try the first try block, and then execute all these. And then when we hit the when we hit the withdraw over here, that one is actually going to disrupt the current execution flow. In some way, you can see, you may have to imagine a little bit. Since there's no more lines after this line for the try block, so skipping the last line is as if you just terminate the try block right away, right? It's just like a special case. So you're going to hit the catch block, and that exception got caught, and then you execute this. But after all these, only this try and catch block get terminated. This one, being independent, still has to be executed, right? That's really the key. And then we're going to say try here and execute this, and then this will also throw the exception for negative radius. So we're going to catch that and then execute it, this catch block. So there's a huge difference over here between the two. And I think what you just explained is really good. Okay. Which one is correct? In this particular case, you cannot say which one is correct, which one is wrong. I would say they behave very differently. Which one you really want to use depends on what you need. If you want to say, as soon as I got one exception over here, I don't want the rest to be executed, you definitely should choose version number 1. On the other hand, if you want to allow this method to have a chance, and also this method to have a chance, even if the previous one actually thrown an exception, in that case, you definitely want to choose the right-hand side version. Okay, which one to use? Again, it's up to you. All right, any more questions? Any follow-up to this? Anyone?
Can we say the left one is more efficient? The right one give us more details?
You can, but when you say efficient, I can see what you mean, because the left one over here, since if there's an error over here, you don't really bother wasting some computing resources to actually execute this. So you're thinking that's more efficient. However, if these two, like a withdraw and also set radius, so these are two independent jobs, maybe eventually you want to accomplish, but one fails, doesn't really mean you don't want to complete the other one. So I would say, when you say efficient, I wouldn't use that word over here. It is true, you might end up only have to execute this method over here, but this method, maybe that's something you don't want to bypass. It's possible. So you may not want to think that way. But definitely, in this case, you can really give a chance for both over here, for both methods over here, and then get some feedback about each one of them. You can say that's more detail. But I wouldn't use the efficient to characterize the left version here. Make sense to you?
Yes, thanks.
Okay, very good. Guys, any follow-up? By the way, this is the final one on the Google Doc, right? That's it, what I can see right before the class. Any follow-up question you want to ask about exceptions? Anything? Okay, hearing none. Okay, So we definitely have some time. I wonder what might be the best use of the remaining time. Of course, if you don't have any further question, we can let you go. That would be one way. Or we can talk about, is there any written test question you want to talk about? I mean, the practice test that I released on eClass. For those of you who tried, do you have a do you want me to go over any particular question together with you? If no, if yes, you got to say it now. If no, I'll let you try still. The practice test question. Anyone?
Are you allowed to go over the practice written test?
Yeah, that's exactly what I'm asking. So I may not go over the entire test because I think I may have to leave a little bit time in case your fellow student got question about Lab 1. So do you have a particular question you want me to go over? I'll be happy to. Do I have more practice questions? I don't actually. Those are the only ones I have. But I can tell you that I'm almost finalizing the written test for Thursday and Friday. You have to definitely focus more on the OOP. I shouldn't say you should focus more. You should definitely pay attention to the OOP pattern that we spoke about in part 2 of the review tutorial series, where I speak about the counter and also the array. Right? That's really the key to really review. Make sure you will be able to trace the code and also answer questions related to it. But for the exception handling, you want to make sure you know how to build a call stack, and also you know how to the idea about catch or specify. Especially, I want you to really make sure you understand what I mentioned about for this particular question over here. Right? Whenever you got a call stack of size, maybe 3 or more, it's not necessarily all the case that you have to propagate the exception to the caller and handle that right away. It's not the case, right? Those kind of concepts you want to make sure you understand them correctly. Okay. Yeah, for the written question, it's not going to be sequential, meaning that once you answer all the questions, you're okay. It's okay for you to go back. You can definitely go back, right? You can always go in random order. How many questions are there on the test? Between 7 and 10, in that range, between 7 and 10, kind of similar to what you have. I mean the number. I'm not saying the topics that's going to be covered. The number of questions will be somehow similar to what you had in the practice test. So I would say between 7 and 10, around that range. Okay. But the practice test is only cover certain topics. You definitely should study all the required materials as listed in the guide. Okay. Is there any particular practice written test question you want me to go over with you? If yes, say it now. Otherwise, I can maybe take some questions for Lab 1. Guys, written test 1 first. Practice written test 1. Anyone? I will wait, pause for one more moment. Once we start talking about Lab 1, then you will have to drop by my office hour if you want to go over some practice test questions. Yeah, if you do the math, of course, you got 20 minutes in total, so you can divide that evenly into the number of questions. But I can tell you that, as I said, some question might be faster, some question might take you more time, right? It really depends. But if you have to answer a particular question for too long, maybe beyond 4 or 5 minutes, then you should be worried, right? So I would say if you encounter any question that you think it's going to take you more time, you can definitely skip it for the time being, and then go back there once you actually finish the rest. Okay, it's a strategy I would use as well if I were to take the test. Okay, final call. Do you have any practice test question you want me to go over with you for the written test 1? Anyone? Okay, I'll presume you're okay with the practice test. And now I can take your questions regarding your Lab 1. Okay, I would say I cannot answer question too specific to your code, right? Just for the protection of your other fellow student. I don't want them to end up having the same code as yours. But if you just maybe get lost about a particular method or get lost about a particular test, you can feel free to say that. I can try to clarify somehow for you. Okay, anyone for Lab 1? Question.
I have a question, but I don't know how to go about asking it.
Okay, you know what? So if you're worried about giving too much information, tell me which method are you talking about?
I'm trying to like the method for get update history.
Okay, sure. Give me one moment. Bear with me. Let me first download your starter code. Okay, let me go from there. Okay. Let me just go to starter. Okay. Okay, it's here. Okay. Yeah. If I need to open that by Eclipse, I'll do that. But for now, let me just go over the concept together with you. I'll give you some conceptual hints if necessary. Okay. Okay. You know what? Let me start from the starter tests. Which one are you talking about? Which one are you failing that you have no idea how to pass?
So I'm failing the one where it's the.
How about give me the line number? I think that will help me.
Yeah, 199. Yeah, 199.
199. Okay, thank you.
Yeah.
199. Is it this line here?
Yes.
Okay.
Yeah.
Okay, no problem. Let's try to understand the flow of this test together, and then I'll give you some hints. Okay. You can see this one is more about testing for the app class, right? Of course, whatever you're going to do is going to be in the app class. So the app class, I presume you already got this constructor there, which will give the name of the app and also the maximum number of rating score that will be allowed for this particular app. Okay, so this you should be okay with this. And then whenever we say release updates over here, so here you got to be a little bit cautious. Let me give you some heads up over here. Let's say if I want to release the updates for 5.7.27, right? In some way, I'm not just adding like a string into the app class, like app objects. What I'm doing here is really to say for this context app object here, I'm basically adding some log objects whose version is 5.7.27. Okay, that's something you want to keep in mind. Okay, I presume that's also what you did. And then, oh, by the way, if there's anything not clear to you, just stop me. Okay, so I can clarify right away. Okay.
You said you add that 5.7.27 into the log class, right?
Yeah, in some way, yes. You can think about, you know, the even though it's only a string value being passed over here, but you don't really just add a single string just to the app object directly. That's not the way to go, right? Conceptually, let me also show you some clarification here. Okay, I'll try to do that as well. Because if you look at section 2.3, let me just go there and I'll explain that. Yeah, so you can see each of these bullet points is quite important. You can always refer to it. Let's say for the app, we say that each app is characterized by its name, right? That's good. And here, a list of updated logs. So this is telling you that in the app class, you should really store a list, like an array of log objects. So what's really an log object is actually described over here. Each log object, as part of it, it will contain the string version. So let's go back to that particular test over there. So if I go back to that test, you can see that when we actually add a version for this app, you do not just add that string value to the app. Instead, you want to add like a brand new log object whose version is this number here. That's what I meant. Is it clear to you?
Yeah, I think I did add it as a string.
You know what? I can give you some analogy here. If you just recall what you did in part 2 of your tutorial series, whenever you want to add, let's say, create an entry, right? You can. We got several versions of how you can add an entry. You can say add an entry, but I'm going to say some serial number, but I'm going to give you the model and also the original price. So the model and the original price both are simply a string and a double. But what we did internally in the add entry method is to create some product objects accordingly. And then we add this product objects into the entry objects. You're doing something very similar over here. You can also refer to that method. You will see some inspiration there. Okay, let me continue. and then you can get a name. That's easy. And also you can get what is new. Think about what is new is really the latest one that you actually added to the app. Okay, so let's now get to update history over here. So I think update history. Think about update history is more about all the logs that have been stored into the current app. You may let's say, for example, this is the very first log you added to the app, and then there's a second one, and that's the third one. So what you will do is the get update history is supposed to return some array. You can see that's an array. That's why you can use the indexing notation here. And the array is going to be size 3 over here. You can see the length will be 3, corresponding to the index 0 should be the corresponding log for this version over here. Index 1 should be the corresponding log for this version over here. Index 2 should be the log objects for this version over here. And you might be wondering, where do we set the detail for the log? This is where it is, right? You can see for the first one, for the first log, which has the version over here, we simply add just one single fix, right? Remember, every update log, you can also add a number of fixes into it. And then for the second log over here, which has the version number over here, we simply added 2 fixes there, and etc. Are you okay so far?
Yeah, I think my problem is that I think I have a string array for the history. I don't have a log array.
I would say, that's a bit too implementation specific. I can give some general hints. I think using a string array is one possible solution. You will just have to somewhere, you have to create the log objects accordingly. Another way to do it is simply create log array. That's also fine. I think both solutions can work. Just depends on where, ultimately, you still have to create those log objects at some point.
Yes. So is it okay if I go a little bit further into where my problem may be?
Okay. You know what? I think my general hints can only go up to here, and then I would say if you got some specific question about why you fell, I think I need to see your code. How about during my office hour? I'm happy to do that.
Okay. Yeah. Do I need to book an appointment for that, right?
Nope. Just come. You may have to wait if there's a queue. 3 p.m. Just come. If you're put in the waiting room, just wait until I grab you. But I will definitely handle your question today for sure.
Okay. Is the link for that is on eClass or on your website?
On the lecture site. If you go there, go to the top, and then you will see the link for the Zoom URL.
Okay. Wait. Where is it?
All right. Go there, and then see on the top.
Okay, I got you. Okay. Thank you.
All right. Okay. Sure. All right, guys. Any other general clarification you might need, I can clarify for you, but I think for any details specific to your implementation, I will need to deal with that maybe during my office hour. I think that'll be better. Okay.
Hey, sir, can I ask something? And then you can decide if it's a general.
Sure, of course.
Okay.
Of course, go ahead.
So, I'm just gonna say it because I don't want to share my screen and risk being in.
Hey, no, you don't want to.
You
don't want to. Yeah, just tell me your question first. Yeah.
Okay, so for the test log 1, where it says assert
test log 1. Okay.
Test log 1, assert equals should be the square brackets equals to S1.
Which line are you talking about? This one?
84. Yeah, right there.
Okay, yeah. What about it?
So for me, that one passes, but then for line 94, my thing.
I think.
Sorry.
Mm-hmm.
I don't know if here. Let me just run it again to be sure.
Okay.
Yeah. Sorry. Log.
Well, I can talk about this method just in general for everybody. I can do that too.
No, okay, so it's a different one. It's in the app section.
Tell me the line.
So line 117.
117. Okay, yeah.
So yeah, that one. I don't know Wait, no, I'm so confused, sir. Sorry, I don't know what's going on anymore. I was okay, so basically I was having some error where I would make one of my two strings equal S1 plus something, and the S1 passed, but then when it had to equal in the test, it would say null.
Then I think in this way, well, if maybe it's better best when I look at your code together during my office hour. That might be the best.
Okay, yeah.
Okay, how about we do that? Okay, no problem.
Yeah, for sure.
Yeah, okay. All right, let me take a look at the chat. Yeah, we don't need to submit a console application because it's not marked. Good, you don't need to, but you wouldn't hurt if you submit it. Okay, here can we go over release updates? Okay, release updates. Okay, I can talk about it. Yeah, give me a moment. Oh, actually, I think Marco, your question should have been addressed, I guess, since I just talked about this particular task, right? So when you say release updates, you don't just want to put a string only, and store that into the app objects. At some point, you also need to create some log objects as well, whose version number is this string over here. Otherwise, you cannot really do things like app fixes, right? You can see app.getUpdate history is an array of update log, like a log. And then you want to go to the first log and then app fix. So the object must exist somehow. Okay. All right, good. And can I elaborate on line number 264? Sure. 264 is actually over here. Well, this one here, well, you can also read it through here, but let me see. We have some app objects like an app, and the app we're talking about is actually GoodNotes 5, right? It's one of the apps available in the App Store. And then we are saying that for this app, we are now submitting 3 as the rating to it. That's basically what we're doing. And we assume that the rating score for each app is going to be between 1 and 5. So that's 3. You can also assume you're not going to submit anything that's outside the range between 1 and 5. So that's what we're doing. Is that kind of what you are expecting me to say, or you're expecting something else?
Professor, I guess it's more about the assert equals right beneath right after.
Oh, you mean here? Over here, right? That's what you meant. Okay, okay, sure. Let me see. Let's read it together. You can also read over the hints as well. Let me just try to look at it right away here. Basically, notice what we're doing here is to say the application.getRating report, right? And apparently the return value is a string value. One thing I want to clarify very quickly, right? Just give you some general hints because you see quite many occasions like this for your lab 1. Okay, let's say, for example, let me just say get rating report specifically. That one there returns a string. Get rating report. And I don't think that one takes any arguments like that. Okay, yeah. Okay. Of course, you're going to do some stuff over here. Okay. Okay. So I think one hint I can give to you is you don't necessarily have to have an attributes, let's say here, because you're thinking that every time we want to call this method, we want to get a rating report. So why don't I have some string value rating report? And then you try to update this attribute value whenever appropriate. That might be one way to do it. However, it's not necessarily the case, right? So number 1, okay, you can do it if you want to, but I'm just saying it's not necessary. And number 2, you can generate a string to return. So something like, for example, you may have something like a string s, maybe some initial value over here. Eventually, you're going to return s. But what should you do over here inside? And this part over here can be done over here. I'll explain that. Okay, That one is going to be returned by going over some array and concatenates. You can use string concatenation, you can use string formats, it's up to you. And concatenate parts from that array. So 1 and 2 are both valid solution. Which one you use, it doesn't matter. Okay, let me go back there to see the formats over here. If you try to see the format of the rating report, you can see it's like the format over here. Let's see the first part. The first part is about reporting the average for the rating, right? And also as part of the average over here, you're also talking about how, it's based on how many ratings. But the number of ratings is only 0. In that case, you'll say not applicable because you cannot divide by 0. So that's the first part, average of how many ratings and for how and what's the average value. And the second part is more like a grouping of all the ratings. I'm saying that how many ratings have we got for score number 5, the maximum? How many ratings have we got for score number 4, the second highest? And how many ratings have we got for score number 1, the lowest one possible? Okay. Is it better for you about this method here?
Yes, it's way much better.
Okay, good.
Yeah, thank you so
good.
much.
No problem. Okay. Guys, any more general clarification I can do for you? Just speak up or put on the chat. Yeah, we definitely do more and more this kind of exercises as we go through the semester. So we have the same formats. We always give you some G-unit test cases and also some comments around them. So you should really try to figure out exactly what you should do. But I can help you clarify if needed as well. Anything else you want me to go over? Anyone? Yeah, if you got any details specific to your code, you're welcome to drop by my office hour. I can let you share your screen and take a look and give you some specific hints. Or you can drop by. We don't have any scheduled labs, I don't think. Maybe you can still drop by the TA hours tomorrow. Okay. Guys, I'll pause a little bit to see if you got any more questions that I didn't handle. Yeah, in case you put anything on the chat or I somehow missed that, forgive me, but you gotta just mention it again in case I didn't see your comments. Anyone? Okay, I'll pause for one more moment before I call it a day, but you will know what to do. You should really, yeah, you're welcome. Okay, let's see. Oh, can I go over practice test question number 6? Sure. Question number 6. You know what? I'm not sure if that's randomized. Let me, maybe it's not. Let me take a look. Number 6. Sam, is it this one? Oh, it's random, right? I thought so. Sam, which question is that? Hello, you're still there? Which code compiles? This one here? This one, right? Okay. Let's talk about it. Oh, that was a good question. Oh, sure. Okay, I'm glad you appreciate that. Okay, good. Okay, let's take a look. Let me put it here and let's talk about it. Okay, it's here. Okay, let's read it together just in case you haven't done so. Okay. So we have a class over here, right? You can see we got private attributes, we got constructor, we got mutator, we got accessor, right? And also we got some line of code to test the point. And then from the following independent lines of code, which means can consider one by one in isolation, choose those which compile. Okay, it's really important, compiles, right? Okay, without any syntax or type error. Let's go one by one. Okay, so this for the first one here, if we say system that out the print line, so whatever that's passed inside must be a value expression. If you want a method call to give you some value expression to print out, it must be an accessor. So if I say p.move up, so p.move up over here is actually a mutator. There's no return value. No return value. So this is not valid. So this will not compile, right? Okay, A should not be compiling. And what about the second one? The second one, we are basically calling the same mutator method here, right? P.move up, right? You're just modifying the X or Y attribute values. So this is exactly how you should use the mutator method. It should be standalone. So this will be okay, right? So this should be one of the answer for sure. Okay, next one. Get distance from origin. Okay, so get distance from origin. You can see that one returns a double. So we are and now we are assigning a double into an integer. All right, it's more like a first year question. So guys, how about C? Should C be valid or invalid? Anyone? By looking at this.
Invalid.
Invalid. Okay, why?
But if it's the other way, if you assign an int to a double, that's okay.
That's correct. So that's good. Oh, let's do a little review. Okay, it's what you learned from the first year. Let's doesn't hurt to do a review. Okay, so if you do double, and then let's say D is assigned to maybe let's say integer I 23, right? If you say I over here, so this is okay. Okay, I think there's something called coercion. So what's going to happen is D over here is going to store 23.0. 0 will be added to the end of the integer when you do that. On the other hand, if you try to do, let's say, the other way around, if you say I is reassigned to D, this is not okay. Unless you do a what?
Casting.
Good. Very good. Which means we should really do a cast integer. Right? This will be necessary to fix it. And for those of you who still remember the word cast, okay, you are going to need that word so much once we talk about inheritance. So the only cast that we learned from the first year to see is about how we can cast maybe from double into integer. In which case we just getting rid of, let's say you got 23 point maybe 7. If you want to cast that into integer, you will just remove the fractional part. That's easy. However, another much more important concept about cast when you talk about OOP is when you do typecasting for polymorphic assignments. That's something we'll talk about after reading week when we speak about inheritance. So cast will definitely come back and we will have a detailed discussion for that. All right. Okay, so this is not good, right? Unless you do a cast. Unless. Okay, what about D over here? Let's take a look. For D, exactly what actually D is not good actually, because you can see P.move up over here, void, right? It does not return anything. So this one does not have has no return value. Right? So this is why it cannot be used as the right hand side as the source of the assignment. So that's not good, right? Okay, move on. Let's see this. What about system that other print line? Good. So that means we're expecting this to be a value. Indeed, it is. Get distance from origin returns a double. We're just printing out a double. So this is okay too. Okay, so this is also fine. So far we got B and also E. The choice order of yours might be a little bit different. Okay, but you can just compare that. What about this one here? You might be wondering about this, I'm guessing. Let's say this one here. P dot get distance from origin. Okay, this one here, I can tell you it compiles, but it's just useless. Remember the question only asks about compilation. Compiles, but useless. And why is that useless? You can see here, when you say p.get distance from origin, you're actually going to call this method here and do some computation. Once you return the value, you're not really using the return value in any way. You're not trying to assign it to other variable. You're not trying to print it out. You're not trying to do anything with it. So it's a waste. So it's useless. But it compiles. The return value is not assigned or printed, for example, right? That's a typical usage for the return value. Okay, so that's compiles but useless. So it should still be considered as a check as far as compilation is concerned. All right, final one. And then when we say p dot get distance from origin, right? You can see here it returns a double, right? So we are trying to assign a double to a double. So that's fine. Right? So that should be the 4 answers, I think. Yeah, B, E, F, G. So that should be the answer. Okay, good. Awesome. Makes more sense. Very good. And guys, for those of you who are still here, let me give you one hint for Thursday and Friday. Make sure you know how to build a call stack. Especially, if I give you a fragment of several classes, you want to figure out what's the caller-callee relationship from them. Okay? Specifically, I want you to review. Okay? It's only for those of you who actually show up today. Oh, actually not here. I'll show it to you. Sorry, let me just go back. I'll show you the page that you should really make sure you understand how to do. Let me go to your lecture notes. And the one I want to go to is here. Here. Remember this one here? Make sure if I give you a fragment of code like this, you will know how to build a call stack, for example. All right, that's my hints to you. Okay. Any more questions you want to ask me? Any more? No problem. I hope the hints will help you. I really hope. And also, you might need some sketch paper for the written test. I'll remind everybody about the sketch paper. I think you will need it. Okay. All right. If no further questions, then I'm gonna call it a day now. If you got any other questions related to labs or other things about the course, reach out to me and then we'll sort it out. Okay. Yes. Are we uploading anything for the test? No. For the written test, everything's going to be done on the e-class. So you will just submit the answer, multiple choice, or type something. That's all you got to do. You don't need to submit any code or something. But for the programming test, you will have to, which I will give you more details later. All right. Awesome. All right, guys, thank you for coming, and I'll see you later. Take care. Bye-bye.